Okay, hello New York, hello Apache Beam Summit. My name is Conall Bennett. I am a domain architect at the CME Group, the world's leading financial derivatives exchange. I'm going to talk to you of our use and success of using Beam over the last few years and current state and future state. I'm going to apologize in advance if I speak a little quickly. It's just what I tend to do. There was going to be a few. I like to construct my talks based on a theme. You're going to see a theme in this. Previous themes I've used while doing talks were like Looney Tunes or AC/DC or Game of Thrones. So given that we're in New York and this is an iconic city, I've chosen Ghostbusters as an iconic movie. So you're going to see that coming up in here. But also whenever somebody who doesn't work in technology asked me what conference I was going to, and I told them it's a Beam Summit, their answer was hilarious to me. It's like, okay, beam me up, Scotty. Right? So you're going to see a Star Trek Ghostbusters mashup in some of the slides here. So watch out for that. And you're welcome in advance. I also do have a quote on how many times I can drop the F word, Apache Flink. I'm going to try to limit how often I do that, but I can't, that might not happen, or we shall see. What do we do? So CME Group, we've been around for quite some time. We operate a marketplace that allows our customers to come and manage their risk, right? So risk generated by geopolitical events, by global health crises like COVID, like dramatic weather events, things that disrupt supply chains that affect natural resources. We operate a platform that allows customers to hedge their risk against those types of events, and trading in asset classes on energy, agriculture, interest rates, cryptocurrency, those types of products. That's kind of the kind of value we bring to our customers. But one of the things that's woven through the DNA of our infrastructure, our systems, and our products that we offer customers is speed. The need for speed. Speed is king. In our ultra-low latency products, we do measure down to nanosecond precision and microseconds, and we're always looking to shave off. We're looking at ways to how we can shave off performance for better products and faster delivery and lower latency. We've also embarked on a journey to migrate all of our business onto the Google Cloud Platform. That started a few years ago. There will be several years more still over that migration, so we're well in the middle of it. And some of the technology for ultra-low latency is still being built to be able to do that. The part of the business that I work in as an architect is around our data portfolio, which is around how we commercialize data for our customers. So we don't work typically with ultra-low latency requirements since we're in the cloud and distributed systems. But regardless of what part of the business is in, our DNA, written into our DNA, is how do we make things faster? So there's always lots of debates around Apache Flink, the F word, and some things like dataflow. In our portfolio, we deal with a combination of different types of products. Some are real-time, where we measure latency in terms of milliseconds and seconds. We do have delayed streams and batch streams, where we're measuring in minutes, and in batch streams, in cases of batch products, hours and end of day. In some of our heaviest workloads, we are dealing with, especially in peak scenarios, in excess of 30 billion units of work in one particular day. And year on year, we see those peak scenarios increasing. So for last year, for example, we've had a peak day with 25 or so billion units of work in one day. And this year up to in excess of 30. And next year, 2025 is not finished yet, but next year we expect that to go up again. So that's a good problem to have in terms of growth and transactions, but that also provides a challenge and an opportunity for scaling our systems architecture to deal with those types of volumes. And again, one thing that we consistently are always working to try to provide better solutions for is dealing with volume, variety, and velocity. So streaming through huge volumes of data as quickly as possible, as low latency as possible, in order to bring that value to our customers. Some of the challenges with that type of data, it's time series data. Ordering is incredibly important to our customers. and 0% data loss is also incredibly important for our most critical products. So dealing with that at high volumes, especially when you have Black Friday events which happen, and whether it's a U.S. presidential election or some sort of military wars broken out or economic war driving volatility and driving transaction, what we have to deal with is also huge data skew. So although we have hundreds of thousands of financial instruments that customers can trade with, in reality, whenever we see those high volumes, it's only a small percentage of those products that drive the volumes and where we see most of the data coming through. So the data is unevenly distributed, and we have to deal with very heavy data skew while we're building our systems. And when we're building our applications in GCP. So just a quick brief history of some of the legacy ecosystem before we started our migration and before we started using something like Beam. A lot of the usual suspects here in terms of frameworks. Some of it's quite legacy, some of it's a little bit more modern, the Apache Flinks and the Apache Sparks, but mainly the picture across the enterprise is it's reasonably fragmented. A lot of siloed teams picking whichever technology that they felt would work for them. There was not a huge amount of collaboration. There was not a huge amount of centralization about which technologies to choose. So we had a patchwork of a lot of different frameworks, a lot of different streaming frameworks, as well as data marts. And that also led to a patchwork of success, really, on how to operationalize and run these in production, and how good we were at that. And when you look back in retrospect, it all looked like quite a high-cost operation with different teams using different technologies to achieve, sometimes similar things, and how they do storage and how they do streaming, and their time to market usually being, a lot of variance in some of those things. So fast forwarding on to when we started getting into migration, beam me up, Scotty, Beam to the rescue to some extent. We identified as we started our migration, certainly in our portfolio, around Apache Beam and dataflow as one of the key strategic services that we used to really help to consolidate down our technology choices to be able, as we build applications. As we went into POCs on things like on Apache Beam and dataflow, a lot of the feedback we got from the engineers doing it was very, very good. Good on multiple different characteristics. Performance was good enough in many cases. Strong observability features that we were always struggled to get out of some of our previous implementations and the technical stacks before. Much better operational usage and insights, and cost efficiency was really, really good as well. So a range of really good things. And people are still saying, but we still like Apache Flink, because it's really, really fast. And again, speed is king, and it's just built in just to go for the fastest thing. That didn't always mean it was the right choice. And also what we found when we were starting to scale up our usage of Beam early on was we were supplementing that with a lot of training. And that training being instructor-led virtual classroom-based training, as well as ad hoc, go take this course in your own time, as well as using platforms like Cloud Guru and others, or finding sandboxes for experiments and people to go and try things out. So as that happened, and this is something that I wanted to emphasize, because rather than going a lot of technical details, it's the team topologies and how we scaled practices across teams. We found that fragmented approach I talked about before around teams kind of doing their own thing and working their own silos started to break down a little bit, because teams were in that learning cycle of how to use a new technology and scale it, and the do's and the don'ts, and what worked and what didn't. Engineers across different locations and geographies and different teams and different portfolios started talking a lot more to each other, right? So although technology doesn't change culture, it can certainly be an enabler to changing culture. And we started to see the organic roots of that as we started to ramp up. First adopter teams, mainly working with dataflow and Beam on stateless pipelines. It's easier to do with varying ranges of complexity in those stateless pipelines. Most of the time it's consuming a lot of data from different topics in Kafka. And it's mostly binary data, SB encoded data, which is optimized for performance streaming. So we decode that data, we normalize it, and then we flush it out to a sink. That's the more simple use cases. In more complex ones, there might be some calculations or aggregations or transformations we apply to the data as we stream it out to that sink. Those were the typical types of use cases that lots and lots of teams do, and dataflow fit really, really nicely into that and worked really well. And again, a lot of really positive feedback from generally disgruntled engineers who don't like new stuff anyway, on this type of service. under the kind of, fast forward 6 to 12 months, as we started launching some of those production, those pipelines up into production, we got a domino effect, and we started to recognize teams saw an economy of scale here, right? So what does an engineer do when they see success in another team? I'll have that, clone, deploy, right? Great, change a couple of things, and that generally did happen. So we got a lot more teams just starting to ramp up their usage as they started to approach their migrations onto the cloud. And really, rather than automatically reaching for the fastest thing, the F word, thinking about, well, what are the things that we have generally lacked in some of our implementations before, which was those observability features, operational cost, toil, manually scaling workloads. So the auto scaling was really something that was really advantageous, and some things that the engineers really liked about dataflow and Beam. And when they looked at those kind of capabilities with the service, and having the scars from previous technologies, I thought, okay, well, actually, there's a real place for Beam here. We don't always need the fastest thing. We like it because it's fast, but it doesn't mean that we always need it. And those other features, which kind of cover well-architected principles, features around resiliency, features around cost optimization, features around operational usage, started to become more important, especially when you've got the scars, the war scars, from having to do that manually before. That really made a case for using something like Apache Beam and dataflow, and teams really started to gravitate towards that. What we also saw was, and I don't like the term center of excellence, I don't believe in it, but certainly a center of expertise starting to form, a distributed remote center of expertise across different engineers in different locations. You've tried things, and doing something as simple as creating a Google space or a chat space where people can come from other teams in the organization and ask questions about this technology and how you've done that. That started to form naturally, and again, those conversations, which were more located in one site, started to become more distributed, more remote across our different sites in the globe. And again, just sped up the speed of adoption for something like this, for Beam and for dataflow. What the graph on the left-hand side really kind of is a very conservative estimate of kind of cost improvements on infrastructure as we kind of migrated some of those workloads. It does not tell the full story. It does not include speed of development that teams were getting from an acceleration from just being that center of expertise that I mentioned, and that kind of velocity. So the total cost of ownership isn't really represented in that graph and is very conservative. The real answer is actually much better and much higher as far as benefits, both on cost infrastructure as well as time to market and speed of development goes. Yes, so don't cross the streams. I love it. And one of the main outputs that we got was kind of circa a year ago. One of the teams started to work on a framework, a Beam framework, which we call our calculation engine, which they put into an inner source code repo that anybody in the enterprise can access. They can clone, deploy themselves, add new features to, modify, and that really became another breeding ground for further collaboration, more than just, here I wrote a nice document which tells you how to do things, here's some advice on Q&A, but now into actual code snippets that people are starting to be able to deploy. So one of the key architectural principles behind the development of this was composability. Right, that was really, really important for us, is composability. We don't want teams to have to be able to reinvent the wheel for their various different products and their various different product lines across the organization. Let's try and make this easy. And as easy as something as simple as a multi-Maven Java project, right? Where a lot of the scaffolding and the boilerplate code for a lot of the similar operations that we do, like streaming data, consuming data from Kafka, decoding it, pushing it out to a sink, whether that's BigQuery, whether it's GCS, whether it's in Kafka again, or PubSub or whatever. All of that's just there. And what this allows you to do, it sounds straightforward, but in my experience, a lot of teams don't do this, is just focus on your business logic, right? And many of the calculations that we do, some of it's pretty ubiquitous, right? So TWAPs, VWAPs, those types of very simplistic calculations and aggregations. Lots of teams do that, but they all reinvent the wheel all the time, right? So putting some of those calculations into the framework, as well as more specific specific and bespoke domain calculations, not only helps people understand how to write Beam code, it also helps them reuse it, right? So it's just Lego block architecture to some degree, plug-in architecture, composability, trying to lower the bar and making it easier for teams to adopt a technology like this. And again, it adds that extra bow in why wouldn't you use this? Why would you pick for something a bit more bespoke, a little bit more niche, and do that yourself? There's no need to do that. One of the things that we also noticed as a pattern starting to emerge was stateful processing is something that, I'll talk about it in a slide or two, that we always struggle with because we need to try to lower the latency down as much as we can, again, for more value. So we did start to find people started to contribute not just specific Beam code, but library code that you can deploy in different compute services, which does a lot of your stateful processing outside of your pipeline. So teams dealing with state up front in their ingestion and starting to pass that into a pipeline instead, rather than dealing with it in the pipeline. So we got, interesting that a lot of more teams starting to contribute Beam code, but also teams starting to contribute code which works with Beam to help with your composability in your pipeline. And this is what that looks like in practice. So what I want to try and draw, might go analog here and use my hand to point things out, but along the top is one particular pipeline from team A. Another one is the pipeline on the bottom of team B. The common denominator is the boxes in red, which is the calculation service that's been deployed. You've got different modules in here that you can use or not use. You pick and choose what you import and use for your functionality here, and two different teams using different numbers of modules, different ingestion pipelines. They do actually use some similar services, and Beam's still in there, similar to what JB kind of talked about in the opening keynote. Data ingestion, we're using Beam. Data processing, we're using Beam. We're using it in multiple layers. And some of the libraries inside those compute services are similar as well, but different complexities. But one of the things that we found is that it enabled rapid product development. From the first time this was deployed to the second product that the team went on to, they said that second launch was 68 weeks from time to market. That used to be months. In worst cases, it could have been a year plus. Right? So we have real dramatic increases in improvement on time to market here. And again, composability being the backbone of that, as well as all the other good features that come with Beam and dataflow. So real big success, and more teams have onboarded to this. And even if a team doesn't use a framework, they can just clone it and just take the parts that they want, and eventually, they become good citizens and they contribute something back. It might not happen straight away, but usually I guilt them into it eventually. Limited use, I guess. I mean, inside the calculation framework, there's a lot of, we try to do a lot of stateless processing. We try and take state out of it as much as possible, again, for those reasons of latency and performance. But, that's kind of one of our main challenges. There's a constant tug of war and debate internally on, should we be using Apache Flink for this? Should we be using dataflow for this? We've reached an economy of scale with using Beam, and dataflow has made it very attractive, and we continue to use it and really use only Apache Flink for really niche circumstances. But stateful processing continues to be a challenge for us, just in terms of reducing that latency. And we are some of our heaviest workloads are constantly brushing up against the quota limits around, how big can your side input be, 80 megabytes, and starting to breach that, as well as, when some of the heaviest workloads are doing 300 terabytes of data shuffles a day, just hitting constraints and limitations with what the architecture and the service allows you to do. So, dealing with state, dealing with it in millisecond ranges is something that we want to be able to achieve more consistently. We've been using value state quite a lot as a caching mechanism, but, there's still, we still brush up against constraints with that, and that's why we've seen more contributions of libraries from people around dealing with state outside the pipeline, although we still, for certain low latency scenarios, still have to try to do this internally inside a pipeline as well. So there's a constant tug of war between, do you want performance and lower latency, or do you want better operational use, better observability, better cost efficiency, kind of faster time to market really as well. And that's something, that even involves the product teams now. There's a lot more deliberate decisions and informed conversations about this, rather than, I just feel like trying this technology over here now, it might work, let's see. Let's really cut out some of those practices and allow us to be a bit more disciplined about how we make the technical decisions. I think on my last slide, so current experiments with Beam, we are trialing, C++ integration for binaries with Java pipelines. So there's, I don't know if it's a well-known, but there's some code out there on how to use the sub-process mechanism to execute binaries on your dataflow workers. We're going to be trialing some of that out for integrating some more legacy, but very fast quantitative libraries inside our pipelines. And interesting what Rakesh was mentioning about the Beam YAML API, really keen to try that out to see if we can lower the bar on, or lower the bar of entry to building a pipeline. So like, product owners and stuff like that can potentially go out and create prototype pipelines and then deploy them, see if they work. So experimentation-based platform really, and using Beam as an experimentation-based platform with the YAML API. So interested to talk maybe actually Rakesh a little bit more about that and see how well because we'd like to try that out as well. More zero downtime pipelines and high availability pipelines going to become really, really important for us right now. So we're starting to get into that. And although, I talked about dealing with state, I know there's orderless state implementation out there. We haven't really used that because it came after we'd built some of our internal implementations already. So we will try and benchmark against that and see if it can. We know that it's going to requires to make some changes. So we're going to try and see how that works out and if it's better. So certainly very keen to try out that functionality. That's me.